Hi, this is your host Swapnil Bhartiya and welcome to TFR Let's Talk. Today we have with us Thana Paris, Director of Open Source at S44 Energy. Thana, it's great to have you on the show.
Thank you, Swapnil.
It's my pleasure to host you here. I would like to know a bit about the company S44 Energy. What do you folks do and how are you associated with LF Energy project and foundation?
S44 Energy has been working in the EV charging space to create custom software solutions for charging networks for about 10 years now. And last year, we launched the open source charging station management system project, CitrineOS. That project has since been adopted by Linux Foundation Energy as a sandbox project. And it's our intent with authoring this project to make charging more accessible, more reliable, particularly for prospective charge point operators.
Excellent, thank you. Now, when we look at EV adoption, of course, depending on how we look at it, yes, in general, it is growing. China is pumping in a lot of EVs in the market. EV adoption is growing in Europe, a lot of countries, other part of the world. But here in the US, we are seeing a totally different kind of story where companies are still trying to gauge. Tesla's revenue were also down. So a lot of people are re-evaluating their EV purchases. And I think one of the biggest concern is not the car itself, but the charging. The time it takes to charge, even if they can fit into their travel habits, sometimes they get to a charging station, it's not working, it's not compatible. Of course, now we are building a standard around Tesla's chargers. So that anxiety is there. So can you talk about when it comes to EV adoption, what kind of role you see the reliability of charging infrastructure plays in adoption of EVs?
It's vital. As you said, the reliability, the accessibility of EV charging stations is one of the biggest problems that people have when they're considering entering into the EV space. And part of the cold feet that many businesses have been having when it comes to entering into the space is the fact that the EV charging networks themselves are very difficult to operate and maintain. Some of this comes down to the commodification of the charging stations. So Tesla has had this leg up from the beginning because they control every aspect of their EV charging. They built the chargers, they built the car, they control the software. But the future of EV charging is going to be much like gas, where there's many different players and the pumps themselves don't really matter. Where you buy them shouldn't be the thing that decides how they're going to operate. So a lot of the businesses now looking at entering into the charging space, they're going to be purchasing EV chargers from many different vendors in order to construct their network. And this has presented some difficulties. There's a lot of challenges to maintaining reliability when there's not a common or consistent way in order to control your chargers and keep visibility into their performance. There's a lot of cases where EV chargers are out in the field and they're broken or they can't put their full power out. So when you come up to them, you plug it in and you're not getting anywhere near to your max charging speed. And sometimes these issues aren't even visible to the operators themselves, meaning they don't even know enough to send someone out to fix the charger. And I think that moving forward, this is an area that the charging space can improve rapidly in, and hopefully that is something that CitrineOS can facilitate.
Since you gave example of gas station, or if you look at example of general electronics, all you have to do is you plug in your adapter in the power supply and it's charging your device. You go to a gas station, all you have to choose what kind of gas you want. Beyond that is 5 minutes and you're done. When it comes to EV charging, what kind of challenges or problems that you see exist? Is it about compatible plugs? Is it about the amount of energy they send, or it's also about the chips that are in a car may not be compatible with the charging station that you're using? So can you talk about the compatibility related challenges or problems that are there?
I see there being both a challenge and an opportunity. So the challenge can come with the way that charging works on a low level. It can be complicated, more complicated than gas, and certainly more complicated than just plugging an appliance in your garage. And there, you can do that when you're charging. They have home chargers that you can plug into a dryer outlet and use to charge your vehicle. And those are essentially just very fancy light switches. But when you go to an charging station, you're dealing with DC fast chargers. And those charge at speeds that a normal outlet in your house could not provide. And negotiating those speeds with the electric vehicle itself is necessary because you can destroy the battery as you're charging. So there's a constant renegotiation between the vehicle itself and the charger to make sure that you are charging safely, which involves a lot of information going along the wire. And that's where the opportunity is. So when you're charging with gas, all you're doing is fueling your car. But when you're charging with electricity, there's a massive amount of information that's going between the car and the charging station. And this information offers opportunities for more insight into the car, into charging itself, and also into making the experience easier. One thing that we can do with EV charging that isn't an option with gas is this notion of plugging and charging, where you plug in your vehicle and it starts charging immediately because it already knows your payment method. You don't need to put your credit card into the machine. You don't need to provide any type of authorization. All of that can be negotiated over the wire because you're not just charging with electricity. There's also information coming between the car and the charging station. So while it is a challenge, it also gives the opportunity for an even more seamless experience with your vehicle.
And if you look at CitrineOS, what kind of problems, what side of problem that you folks tackle with?
I'm gonna break this down into two different answers. One, you brought up that when you're not using Tesla, you often have a third-party application that you're looking at. The EV charging space in America is younger, less mature than the EV charging space in, say, Europe. And one of the problems that Europe came across pretty early as they were building out EV charging infrastructure was that you can have many different operators. And so whose app are you going to use? It's right now in the US, there's only a small number of charging networks. So you can think of it as having one app per charging network. But there are areas, metro areas in Europe where you may have 30 different operators. And it makes no sense to have 30 different apps on your phone. So instead, there's this idea of roaming, where you have one app and it can allow you to charge at many different charging stations. And since this is so important to EV adoption and to being able to use the infrastructure that the government is paying for, governments in Europe are already starting to regulate this space, demanding that they be compatible with this roaming so that all chargers can be visible on a common plane where you can have one app and see all the chargers that are being operated in your area. And as for CitrineOS and how we fit into this picture, so the chargers themselves need to be operated remotely. There's a lot of data that, as I mentioned before, comes over the wire between the vehicle and the charging station. And all of this data is being reported to the cloud and is vital for being able to operate the chargers, to make sure that they aren't broken, to make sure that they're behaving correctly, and to bill the customer in the end, as the rate of charging is vital for how the customer might end up being charged for their session, billed for their session. CitrineOS is focused on a protocol called the Open Charge Point Protocol. We refer to it just as OCPP. We like our acronyms. This protocol has been dominant now in the space for more than a decade. But the version of it that has been used is 1.6. And what you use OCPP 1.6 for is to connect your charger to the cloud. And the information that goes between your charger and your software in the cloud is mediated by this protocol. The reason this is important is because charging networks will use chargers from different vendors. As I mentioned, we're in the process of commodifying the chargers themselves. Because as it started, DC fast chargers like Tesla had completely proprietary controls. So if you, as a non-Tesla company, were to somehow purchase a supercharger, you would not be able to operate it unless you paid Tesla for proprietary software. OCPP is trying to level this playing field and make sure that chargers are intercompatible across networks and don't require proprietary software in order to operate them. This is particularly important from the perspective of a government that's rolling out support for EV charging. If the money that it's spending to create this EV charging infrastructure is being spent on chargers that won't work except for the company that created them, then the lifetime of that infrastructure is tied to the lifetime of that particular private industry player. And that's not a good thing for the future of the infrastructure of the nation. You don't want it to be leased from the private industry. You're paying for that infrastructure. It should last beyond just the lifespan of that one business. So the OCPP infrastructure will allow players to buy charging stations from many different vendors and then operate them under one common software. And that software needs to provide insight into the charger's behavior that will allow you to handle things like it breaking or overheating. And the current version of the protocol, 1.6, the older version that's more commonly used, doesn't give you the type of insight that's required to properly maintain these chargers. And CitrineOS uses a newer version of the protocol, 201, that gives very rich, deep insight into the status of the chargers and lets you take action in order to make sure that they will continue working.
When I was listening to you, one more thing that I wanted to ask you is that if you look at the US market, at least, we have kind of established Tesla's fast charging network as the de facto for the whole industry. Now, Tesla has also opened up its charger for other players. In some states, even governments have mandated that it should be Tesla's charging station. There are a lot of, of course, political reasons and politics of with global climate change, all those things, it becomes a political issue. But politics aside, when we look at establishing a company's technology as the standard for the whole industry, it does require a lot of things. First of all, is Tesla's this charging network open source? Is it open protocol? Do companies have to pay a fee to use this charging station? Also, Tesla recently fired or lay off the whole EV charging team as well. We don't really know what their long-term strategy is with the EV market, as Musk's focus is shifting to AI, X, and XAI, which also raises a question. Also, it leads to another problem, as we were talking about earlier, what the charging networks reliability. Now we are talking about the sustainability because we are relying on one vendor. So what are your thoughts on the whole charging landscape in the US, at least, which is more reliant on Tesla's network?
Tesla has been a dominant player because they've given the best user experience to date. But they have not this whole time positioned themselves to domineer the industry moving into the future. And part of that has to do with technical standards. So when we say Tesla is the standard, what we really mean is it's the gold standard. It's the party to beat because they have a seamless user experience. And that's what everybody is comparing other players in the industry to here in the US. But when we're looking to the future of the EV charging industry, they can't maintain that advantage forever. People are working to make these experiences better and better. And Tesla is aware of this. So when we talk about Tesla having open sourced its standard, what Tesla actually did was adopt an existing open source standard that had been established in Europe. So one of the competing plug standards was called the CCS plug standard. And there are two parts to a plug standard. There's the shape of the plug, but then there's also the information that comes through the wire. So what Tesla did is they adopted the same communication standard as CCS. So they took the way it works for that plug and they made it work the same way on their plug, even though the plug itself has a different face. And in this way, cars that were already able to use CCS chargers, which was the majority of the industry, could now just use an adapter and use a Tesla. So in reality, Tesla didn't set the standard. They were, in fact, adopting an already pre-existing open source standard that was very robust and had already become dominant in the market. And we're going to see something very similar happen with the control layer that I was referring to. In many places in Europe, it's already becoming a regulation that you must have an OCPP control layer. And so Tesla has already announced that they are in the process of adjusting their supercharger software in order to accommodate these standards. And in fact, in Europe, as I mentioned, roaming is also something that is mandated. And they have also begun working on that software for Tesla. It's complicated because it's unclear what Tesla's commitment is to the future of its charging network. Presuming that they continue to want to expand, presuming that they continue to want to pursue market dominance in EV charging and not just be the manufacturers of Tesla vehicles, but also a major charging network in the US and worldwide, they will continue to need to adopt these standards in order to keep up with everyone else's progress. And if they don't, then they will be the ones who start seeming unreliable because you're not going to be able to see them in your favorite app that has every other charging network. And they're not going to be able to keep up with the technological advancements of the other networks who are working off of a common platform where everyone's progress can be used to help the entire industry.
If you look at all of these challenges, whether it's about compatibility, whether it's about interoperability, whether it's about sustainability because of reliance or a single vendor, what is the larger community? What kind of work folks like LF Energy or folks at S44 Energy are doing to create an even playing field to have a long-term, more sustainable plan for EV market, which is not tied to a specific vendor?
So the manufacturers who make EV charging stations, they maintain both a communication layer, an OCPP communication layer that their customers use, and they also maintain a back channel, a proprietary way to look at their chargers that lets them have deeper insight into the behavior of the charger. One of the big goals of Linux Foundation Energy and an open source development in EV charging as a whole is to try and displace what is currently seen as the major value add for EV charging. We're in such a young state right now in this industry that having chargers that work is still a value add. And that's not great. We want it to be the assumption, the baseline, that a charger will work, that it will be reliable, that it will have its max power output, and that if anything is going wrong with it, it will be immediately surfaced and handled. And then on top of that, the value adds could be things that truly deepen the customer experience. We don't want the thing that distinguishes charging stations from each other to be that they work. And CitrineOS, in its efforts to create an open source platform for the OCPP 201 protocol, is trying to make it so that this standard that could be adopted by every charging station vendor can be used to properly maintain and operate these chargers so that this is no longer a value add. This is no longer something that you need to have a separate communication, a separate proprietary communication layer in order to maintain. We want a common layer that the clients who purchase this hardware can use that make sure that these chargers will work now and into the future and across their lifespans up until they need to be replaced, not because they were broken since we weren't able to see that they needed to be repaired, but because they truly have run out of time and now it's time for faster and better chargers.
And can you also talk about what kind of players are involved with the development, maintenance, the whole project around CitrineOS?
So the project has been authored by S44 Energy, and we've had one major contribution so far from a small company called Stackbox, in the form of a module that works with Citrine that permits you to pay for a charge via the payment processing platform called Stripe, which is a commonly used platform that's very easy. It's just a payment portal, lets you put in a variety of different payment information and simplifies the whole experience. And it's our hope with the way that we've designed the software that it becomes very easy for companies to create add-ons and modules that expand the functionality of CitrineOS. It may have started with OCPP 201, and that may be its backbone, so to speak. But it was also designed with a future-forward mindset that we would make it easy to integrate and easy to extend.
What kind of players, what kind of organizations should get involved with either CitrineOS or LF Energy? Are we looking at players like Ford, who are, of course, car manufacturer, or we are looking at the players in the charging space? And why?
It's our hope that many of the parties who stand to benefit from the standardization of this communication layer would be interested in contributing to this project. And this can involve original equipment manufacturers, OEMs as we call them, such as Ford, who make the cars. It can refer to the hardware vendors like Switch EV or Alpatronic or ABB. These hardware vendors also stand to gain by making sure that their platforms are compatible with a common protocol, because that's increasingly a priority for their customers. Their customers are anyone looking to become a charge point operator, to create their own charging network. And because people are so nervous about buying an EV because of the charging anxiety, the OEMs themselves are actually looking to become the major investors in expanding charging infrastructure. So a lot of companies have announced large projects for the future charging networks, such as Mercedes-Benz and others have said that they will create large charging networks of thousands of chargers very soon here in the United States. And they don't want to have to buy all of their hardware from one source. So it's a selling point for the charger manufacturers to be compatible. It's majorly useful for the OEMs to be able to have a platform that control all the different charging stations. And it provides trust. Even competitors to CitrineOS, people who have their own charging station management systems, will benefit from having a reference implementation, a trusted open source implementation that makes people more confident in entering the space. And it's our hope that any or all of these players might eventually be interested in contributing to the project or just using it and helping us make sure that it's the best it can be.
Can you also share, no pun intended, what kind of things are on your roadmap? What are the things that you folks are working on when it comes to CitrineOS?
The project was based on the Open Charge Point protocol, and that allows it to control chargers. But there's more areas of improvement in the future that make Citrine useful on a higher level. I mentioned, for example, roaming. The most recent release that we had was supporting a new protocol to Citrine. It's been in the space for many years, but to Citrine, it's a new protocol, um, OCPI, which provides the ability to roam. It means with an OCPI layer, you can have your chargers be accessible to mobile apps that will show customers these chargers and their status so that they can be used. It could also be on a dashboard. So on a car dashboard, when you look at the map and you see chargers, the ability to see those chargers from many different networks is powered by these roaming protocols, of which OCPI is the most common. And looking even further forward beyond cloud control of these chargers and roaming, there's integration with utilities. So one question that has been on the minds of investors in the infrastructure of EV charging is how this will interface with utilities, because there's a worry that we're putting a lot of strain on the grid. There's also a hope that having many electric vehicles out there will provide an extra sort of base load for utility grids by charging not only from the grid to the vehicle, but also from the vehicle to the grid, and providing a large number of car batteries as sort of an extra buffer for the utilities that we use. There's protocols that govern that interaction as well between the chargers and these utilities that power the grid. And that is also an area that Citrine is looking to expand into. There's a protocol called OpenADR, which has been seeing slow but steady adoption among utilities, not only in Europe, but here in the US, particularly in California. And that protocol layer would allow charging networks to interface with the utility and possibly prevent any overloading, and also maybe add value in the form of extra stability to electrical grids.
Thana, thank you so much for taking time out today, join us today, and talk about this very complicated EV charging space, especially in the US. But thanks for sharing all those great insights. Thanks for giving us a good overview where we are with the EV charging space. And I would love to sit down and chat with you again as more progress is made in this space. But I really, really appreciate your time today. Thank you.
Thank you, Swapnil. Thank you.